Greetings, Mr. Sutton here with the AB Calculus Derivative Extra Practice number 8 solutions. To find the derivative of this expression, I'm first going to rewrite this second term with an exponent. So this can be written as 6x to the 3/2 power. And now let me just use the power rule. We've got 3x squared for that first term. And then for this one, we have negative 6 times 3/2. That's going to be negative 9x to the 1/2 power. On this one, I'm going to have to use the product rule to take the derivative. So I have u prime v plus uv prime. Let me use the box and ribbon to organize all that. So I have my two factors, e to the x and sine of 6x plus 2, and their derivatives, which are e to the x. And let's see here, we're going to need a chain rule. This is sine of something, that's the outer function. So the derivative of that going to be cosine of something, so cosine of 6x plus 2, times the derivative of 6x plus 2, so that's a 6 also that's getting multiplied by all this. So we're going to have 6 cosine of 6x plus 2 for that derivative. And now multiplying it back out using my ribbon, we've got e to the x times sine of 6x plus 2. And then we've also got plus, this is going to be 6 e to the x cosine of 6x plus 2. That'll be the uv prime part of all this. To find the derivative on this problem, you're really going to want to use your log rules to break this up. If you try taking the derivative the way it is, you've got a chain rule with a product rule inside a quotient rule. What a mess. So using log rules, we're going to turn whenever we see multiplication, we're going to turn that into the addition of logarithms, and division is going to turn into subtraction of logarithms. So splitting this up, I can write ln of x cubed plus 3 plus ln of e to the x, because we were multiplying these, so that becomes addition of logs, and then minus ln of radical x squared plus 1. We're going to use a few more log rules, the pop-out rule specifically, so I can't really do anything with this first expression, but this next one, ln of e to the x, well, I mean ln and e just cancel out, so this is just x. And then over here, all the stuff inside here is really being raised to the 1/2 power. So I can pop out a 1/2 in front of all that and write minus 1/2 ln of x squared plus 1. And at this point, I've avoided doing calculus as long as I can. It's time to actually take a derivative on all this stuff. So for this first term, we basically have a chain rule. We have ln of something. Derivative of that is going to be 1 over the something, 1 over x squared plus 3. Times the derivative of x squared plus 3, which is going to be 2x. We'll put that in the numerator. Plus derivative of x is just 1. And over here, this is another chain rule. This is going to be 1 over the something. So 1 over x squared plus 1. And we have a 2 down there actually. So 1 over 2 parentheses x squared plus 1 times the derivative of x squared plus 1. So that's another 2x going in the numerator. For this derivative, we're going to have to use the chain rule. My outer function, I've got cosecant of something. Derivative of that's going to be negative cosecant of the something times cotan of the something being arctan of x squared. Now we have to take the derivative of something, derivative of arctan of x squared. Well, that's another chain rule. We have arctan of something else. That's going to be 1 over something else squared plus 1, so 1 over x squared squared plus 1, which I could simplify, but why bother? Now we have to multiply by the derivative of x squared, the innermost function, and that's multiplying by 2x. On this problem, I'm going to need a chain rule using some of my exponential derivative rules. The outermost function, we have 3 to the something. Derivative of that is going to be 3 to the same something times ln of 3. Next, we have to multiply by the derivative of the something. Well, the something is e to the x to the 4th. So derivative of e to the something, because we've got another chain rule in there, is going to be e to the same something. So we're just multiplying by e to the x to the 4th. Not a very exciting derivative, but wait, there's more. We have the derivative of x to the 4th now that we have to multiply by, the innermost function derivative, and that's going to be 4x cubed. For this derivative, we're going to have to use the chain rule. Our outermost function, we have log base 6 of something. Derivative of that is going to be 1 over the something, the x cubed minus sine of x, times the ln of the base, times the ln of 6. But wait, we're going to have to multiply by the derivative of the something now. Derivative of x cubed minus sine of x. And that's going to be 3x squared minus cosine of x. To find this derivative, we're going to need the chain rule. My outermost function, I've got cosine of something. Derivative of that's going to be negative sine of something, negative sine of cosecant of 3x cubed. Next, we have to take the derivative of cosecant of 3x squared and multiply by that. This is another chain rule. This is a cosecant of something. That derivative is going to be negative cosecant of something, cotan of something, the something being this 3x cubed. And finally, we have to take the derivative of 3x cubed itself, which is going to be 9x squared. This problem looks a little bit scary until you realize that tan and arctan are inverses. Tan and arctan are going to cancel each other out, so this is really just 4 to the 5x, which is just a little chain rule. We've got basically 4 to the something. The derivative of that is going to be 4 to the something to the 5x times ln of 4 times the derivative of the something, so that's going to be multiplied by 5. On this problem, since we can't really isolate y, we're going to use implicit differentiation, which means that whenever we take the derivative of something with y, we're going to treat y as a function of x, its own function, and multiply by the derivative of y, dy over dx. So doing that process, starting on the left side here, we immediately run into a product, y times sine of x. We are going to have to use the product rule for this. So let me get out the box and ribbon. We've got y and sine of x. Derivative of y is normally 1, but we have to multiply by the derivative of y. So this is actually 1 dy over dx. And then sine of x derivative is going to be cosine of x. So we use the ribbon to multiply this out. We've got sine of x dy over dx plus y times cosine of x. And now that's going to equal, let's see here, this is going to be 8y times dy over dx. Next step, we have to get all the dy over dx's on one side, everything else on the other side. So this sine of x dy over dx can stay on the left. And this 8y dy over dx, we're going to subtract that to get it over to the left side. Let me subtract this y cosine of x to move it to the other side. And now that I've done this, I can factor out a dy over dx. So that's going to leave me with sine of x minus 8y inside of parentheses. And then to get dy over dx by itself and get the derivative, I just need to divide by this parentheses. So negative y cosine of x over sine of x minus 8y is my final answer for this one. To find the derivative of this function, we first have to notice that there is a variable in the base and the exponent, and there's really no way to get around that. So we're going to have to use logarithmic differentiation. We'll start by taking the log of both sides. I'll use ln specifically. So we have ln of y on the left side. On the right side, taking the ln pops out this secant of x, so that's coming down to the ground level here. And we also have ln of the base, ln of arctan of x. So now implicitly differentiating this thing, we have 1 over y, dy over dx on the left side. On the right side, we have a product rule with secant of x and ln of arctan of x. Derivative of secant, that's going to be secant of x tan of x. And here's v prime. This is derivative of ln of arctan of x. So that's going to be 1 over arctan of x times the derivative of arctan of x. We got to use the chain rule here. So that's going to be 1 over x squared plus 1. So multiplying all of this out using the ribbon pattern here, we've got secant of x tan of x times ln of arctan of x. All that stuff is u prime v, plus now the uv prime part, we're doing secant of x over arctan of x, x squared plus 1, all that stuff. We still haven't actually got the derivative though. We need to get dy over dx by itself. So to do that, I'm going to multiply both sides by y. That'll give me y times all the stuff on the right side in a big parentheses. And you could call it a day on this one, but if you wanted to get everything in terms of x, you could substitute the original expression here back for the y down here, and sometimes you have to do that. You didn't this time around, but hey, here's an alternate answer. To find the derivative on this one, there's a few things we have to do. This first expression here, we have a chain rule going on. We have something to the fourth power, so the derivative of that is going to be 4 times something to the third, so 4 times that product to the third power. But now we have to multiply by the derivative of x ln of x, and for that we are going to need the product rule. So let me get my box and ribbons set up over here. I have factors of x and ln of x. Derivatives are going to be 1 and 1 over x, so not too bad. Using the ribbon to multiply that out, we've got ln of x plus, well, x over x is just 1, and that's all in a parenthesis, so I don't lose anything. And then finally, we have a derivative of 6x, which is just going to be a plus 6.